Hello, in this video let's discuss fourth question of today's contest. There is an endless straightless line populated with some robots and walls. You are given in integer arrays, robots, distance and walls. Robot is the position of ith robot. Distance is the maximum distance that the bullet can travel. Walls is the position of jth wall. Every robot has one bullet that can either fire to right or left at most distance of 5 meters. A bullet destroys every wall in its path that lies within its range. Robots are fixed obstacles. If a bullet hits another robot before reaching a wall, it immediately stops the robot and the bullet cannot continue. Return the maximum number of unique walls that can be destroyed by the robots. A wall and robot may share same positions. The wall can be destroyed by robot at that position. Robots are not destroyed by bullets. It is already given. The constraints are n is up to 1 if the length of distances all are up to 1 if and the values are up to 1 in n and the distances are up to 1 if and values are unique in both walls and robots. So for now, let's forget about the answer and let's think what are really required for the question, and then we can think of the answer once we try to get all the things what we want. So firstly, we have different robots and we have different walls, and this indicates the distance that the maximum bullet can travel when it fires in any of the direction, right or left. So in this example, let's assume that this is the final configuration that robot walls and distances can be configured to. So now what we want. So firstly, we can hit bullet right or left, and we want to find the maximum number of walls that can be destroyed by all the robots combinedly, making any of the directions right or left for any other robot. So for example, we have a robot R. So firstly, we have two choices, right and left, and let's assume that when R1 hits right, the range of distances, the x coordinates that is the x coordinates that will be affected because of this robot firing a bullet in right are 2 and 10. So 2, 3, 4 and 10 till 10. So these are the units that will be affected. And now, but the main goal is not about the position of x coordinates, but the main goal is to think about the wall positions because we want to return the maximum number of walls destroyed. So firstly, we want to find the walls destroyed when a robot fires a bullet in another direction, but not the x coordinates. So firstly, from this what we got. So from this, for every robot, we have two choices, right? And we have two different choices, two different pair when a bullet is fired right and left. So for every pair, we have to find the indices of walls that are covered because of in that range, so that we can try to find at least walls destroyed by each robot in any of the direction. So from this what we got, from x coordinates we want to get a function where it will return the range of walls. Here we have 210 x coordinates, but we want range of integers where they are the, for example, L and R. So we want L and R such that all the integers from wall of L to wall of R are destroyed by single robot firing a bullet. So we have LR, we want wall index L, wall index R. For example, let's assume that L to R is 4 to 11. So these all indices are affected by firing a bullet by robo in some right direction. And now let's assume that these are the wall positions 2, 4, 6, 9, 11 and 14. So from this, we want, this is the L and R, but we want the indices of walls such that these are affected. So how can we find? So the least index that is affected is 4. So what can we do? So we need the first index in walls such that it is greater than or equal to 4, so that this will be affected because it is in L to R. This next can be affected because this may be in L to R, and so on. Till what index? It can be till the last index. So the highest index is 11. So we can find the rightmost position in the walls that is greater than or let's assume that we are finding for greater than 11. So let's assume that this is 12. So if we find the 12, then all these indices are affected. So from this what we got, we can use of binary search because we can sort a wall's position, and for L to R, for L we can find the least index such that this is the least index of wall such that it get destroyed because of L to R. And similarly we can find upper bound of R plus 1, we can find upper bound of 12 so that all indices till that before will be destroyed. These are the walls indices that are destroyed by this L to R 4 to 11. So lower bound of L and upper bound of R plus 1. Upper bound of R plus 1, so that we can try to find the why we are using upper bound of R plus 1, not only upper bound, not like lower bound of R, because there may be many walls. So we can just try to, for a safe case, we can try to do upper bound of r plus 1, and then for example this is the upper bound of r plus 1. So this means that obviously all these are surely less than or equal to 11. So then we can try to find the answer in safe case. Maybe there maybe walls are unique, but if the walls are not unique, then we can try to use upper bound of r plus 1, and then we can subtract from 1, so that till the before index we will get all the indices covered. So from this what we got, given indices L and R, we got how to find the wall indices that are covered in that range. So now we got walls covered in both right and left. So for every row we can find its coordinate minus maximum distance and coordinate. So this is the this is L and R that are covered when the bullet is fired left, and similarly we can do for right. And then for every case we can find the walls indices range that are affected by L to R. So now we got, and now let's come to the main idea. And now we want the maximum walls that are covered by all the robots, effectively killing all the walls, effectively destroying all the walls. So how can we do this? So let's say we are at robot I. So we are at robot I. Then what are the things required to find the answer? For example, we are thinking about I. We are starting from zero to n minus one. So at index I, what we want to get the answer. So before thinking that, we have two choices here, right? We can, the robot at this can fire in the left or fire in the right. So given these two choices, we have to find what are the other information required to get the correct answer. So let's assume, for now, let's assume that we are choosing left. So what we want, so the present robo is choosing left. So if it is choosing left, so what we want to find answer. So we want about the previous robot, right? Because we are at 0 to I. So when we are at I minus 1, we discussed that we are coming from 0 to n minus 1. So we are at I minus 1. So I minus 1, we already got our answer, and now we are thinking about it. And at I, we are choosing left. So if we are choosing left, we just simply want is, we just simply want the index, right? So given index, we can maintain two states, like we can maintain two types, where the first one is the robot chosen in the right direction, chosen in the left direction. So for example, we have function of I. So what does function of I returns? It should return the maximum answer possible when uh, when thinking about robot I, till robot I. So only function of I is sufficient. This is sufficient, but it is better to keep the function of index and direction, so that we can leave the choice of direction as a parameter itself. So for example, function of function of 3 comma 0, what it means, it means that the maximum answer possible till index 3, such that index 3, the robot in index 3 fired the bullet at right. So 0 is right and 1 is left. So function of 3 comma 0 indicates that the maximum answer we got till index 3, such that the robot index 3 fired the right bullet. So in this way, if we have the function of I and direction, it is better to think about index I, because at index I we can think about the previous robo, because from 0 to I minus 1 we got the best answer. So now we have to think with respect to I. So without thinking with respect to each and every, we can just think about last robo, because we kept all this in the brain while solving for I minus 1. So for I, it is simply better to think till I minus 1. And for I plus 1, we will think only about I, because this was already stored correctly when coming from 0 to index. So now what we got? So we got that the function of index I and direction are the things required to get the correct answer. Till index I and I robot fired in direction dir. 0 is right, 1 is left. So, and now, for now let's assume that this is also choosing left, and the past one is also left. We have answers stored for both left and right for I minus 1. But for now, let's assume that we are thinking about left, and about this also we are thinking about left. So if this is the case, then is answer not directly the number of walls affected by this left plus the number of walls affected by this left? No. Why? Because they may overlap. So if they are not overlapping, then we can simply add the answer and then we can get. But they're overlapping, so we cannot simply directly add. So let's take an example. So we are at this one and we are at this one. So we are choosing both as left. We already have answers right and left for I minus 1. For now, let's think we are assuming the I minus 1 as left. So this is left and this is also left. So the walls indices affected are 0 to 3 here, and the wall indices are 1 to 6 here. If you observe, 1 and 2 and 3 are common in this both. So we cannot simply add all of these. Why? Because 1 to 3 are 1 to 3 are overlapping, and these are double counted. So from this what we got? So we got two pairs, and we cannot simply add the total number of walls. We want to subtract the walls overlapping. So we got this also. And now let's try to think of all the possible cases. So we are choosing the present one as right. If it is right, we have two choices, right and left, for before also. And if we are choosing this as left, even now before one has both R and L, so we have four total options. We are assuming the present one as right, and then we have two choices. For the last one, which to consider, and we are choosing the present one as L, and even now we have two choices to consider for the last one, whether the last one chosen is right or left. So, and now let's discuss how can we do correctly. So simply we got that we are using DB because function has overlapping subproblems. So let's assume that we are doing for index I, and we are thinking that the robot I will fire the bullet right. And now we are trying to find the best possible answer for right. So what is the DP state for this? It is simply DP of I of 0, because we assumed that 0 is right. So DP of I of 0 is exactly what we want. And how we can compute that? So for right, for the before we have choose two choices R and left, right and left. So let's think about right first. So for now we are assuming that I minus is also firing it right. So now let's take some example. For assume that the walls of I minus 1 when choosing right are 2 to 6. So when robot I minus 1 is firing a bullet at right, 2 to 6 are the indices that are affected. And now even we assume that we are choosing right at the present index for the present robot. So what are the walls that are affected by by firing the bullet the robot I at the right direction? They are 5 to 9. So this is the before one and this is the present one. So now what is dp of I of 0? That is what we are going to find, right? So what is dp of I of 0? Having the information dp of I 0, I minus 1 0. So we have this already. So for example, this is the one we have. So if there are no overlapping, for example, the before one is also 2 to 3 and the present one is 6 to 9. So there are no overlapping, so we can simply add. So if there is no overlapping, forget about this for now. Forget about this for now. And then dp of I minus 0. This is the walls destroyed by I minus 1 at choosing right. And now we assumed that there are no overlapping. So we can simply add the walls covered by right also by the index I. So we are at this, and so we are assumed that both are right. So we are at it. So we got the answer dp of I minus 1 comma 0. So this is the number of these are the number of walls that are destroyed when the I minus 1 robot chooses right. And now we are also choosing right for this. So what are the extra number of walls that can come? So this is the original wall still I minus 1 plus the new walls that are destroyed by this one. So this is what exactly I have written. The walls covered in the right, the walls destroyed when we are choosing right for indexing. So this is the count, where this is the old count and this is the new count. But there may be overlapping. So we are subtracting the overlapping number of walls between the right of I and I plus 1. Why right? Because we assumed that both are right. So what we are discussing that both are right. So for now let's assume there is no overlapping. So let's assume that dp of I minus 1 comma 0 gives the maximum number of walls that are destroyed when the before robot before robot chooses right. And now also we are choosing right. So because of choosing right, because of choosing now right, what are the extra walls that are destroyed? That is what this is. Walls covered of right Fi. This is the old walls, this is the new walls, and minus the overlapping walls of these both. So here overlapping of 2 6 and 5 6 5 9 is what? They are 5 and 6, which is 2. So 5 and 6 are only two indices that are appearing in both, and count is 2. So we are double counting 5 and 6 twice. So we are simply removing this. So from this we got the transition also. So having dp of I minus 1 0 and 1, we can find dp of I and 0 and 1 by finding our overlapping correctly and number of walls correctly. So how can I find those both? So walls covered right. So this is the one we want for every index, and walls covered left is also one we want, because here we assume that we are firing right. So this is right. So there may be a choice we have considering left also. So we want left also. And then we want other function also, where it returns the overlapping count of overlapping indices between pair P1 and P2. What is pair? It is simply the range. So 2 to 6 range indicates pair 2 to 6 and pair 4 to 9 indicates 4 to 9. So given these two, this have to return the number of overlapping count so that we can subtract from the answer we got. So let's assume how can I find this. So walls covered rate, what it means, for example, we have 4 and 6. So if this is the pair parameter to this function, we have to return 3 because 4, 5, 6, these are the 3 indices that are walls, that walls are it, and these are affected, these are destroyed by the present firing. So if any of it is -1, why -1? Because there may be a case where any wall is not destroyed by any robot. So then we are initializing both by -1, which indicates that the robot is useless because it cannot fire in any direction and it cannot affect anyone. So if that is the case, if any of it is -1, then there is no meaning of covering the walls because even though we are firing this, there is no use because there are no walls affected. So if any of this -1, it is simply 0 because this is not useful for destroying any walls. So if it is not the case, then what? It is simply the count. So for 4 to 6, what are the walls affected? It is 6 minus 4 plus 1, which is 3. So even similarly left, the same is the case with left. So we got this both. But how to find overlapping? This is also very simple. So let's assume that the first pair is 2 and 7, the second pair is 8 and 9. So if this is the case, then what are the overlapping? They are 0. Why? Because the first one is 2 to 7, the second one is 8 to 9. So there are no overlapping. So it is 0. And what if the first one is 2, 7, the second one is 4, 6? Then 4, 5, 6 are overlapping because they are in both. So how can we find that? So we have two pairs and we have to find overlapping. So let's assume that this is the first point of pair 1, which is 2 here, and second point of pair 1, which is 7. And similarly P2F and P2S. So given these two, how can we find whether they are overlapping or not? We can just observe P1S and P2F. So for example, if it's 2 to 7 and 8 to 9. So 2, 7, 8, 9. So if it's 2, 7, 8, 9. So what is this? This is P1F, P1S, the second coordinate of the first pair. And what is it? It is P2 first. So if P2 first is greater than P1 second, it means that there are no overlapping, right? If there are no overlapping. And what if it is 2, 7, 4, 9? And then they are overlapping. And how many? So it is simply the points between this. And what is that? It is simply 7 minus 4 plus 1. So given two pairs, we can simply find what are the overlapping by getting these two indices, these two values. So we got the whole solution right. At every index, we can choose right or left. And if we choose right, so if we are choosing right, we have choice to consider for lost also because we already have dp of I minus 1, 0 and 1. So for we will do both choices differently and we'll subtract the overlapping count and then we can get the correct answer. And finally, after traveling the whole array, we can simply return dp maximum of this and this so that we can choose to fire the last one right or left. We want the maximum wall, so we are simply returning the maximum. So hope you got this. Let's check the code. So simply make the, so in the code we discussed about one thing, right? Yeah. So here, when we are trying to convert some range to walls, we forgot one thing. What? Because it is given that when a robot, for example, a wall is, this is other robot, and this is wall, and some bullet is coming from this, and the distance is up to till this, right? So it is given that when a bullet is reaching a robot, it will stop. It will not go to next walls. It will just stop here. So how can we do that in this? So we can simply make a small minimum. For example, we are traveling to all the robots. We are getting the coordinate and maximum distance that it can travel. So RS is the distance, RS is the start, and RE is the end position where it is P, the present coordinate, plus the distance can travel. So RS is robot start, RE is robot end. And so this is the case where we are doing the before case. So this is the next robot position. So it's the next robot position, and we are making minimum with RFI because, so assume that the current bullet can reach from 4 to 11, but the next robot is at 7, is at 8. So if the next robot is 8, the bullet cannot go through the next set of indices. So combinedly, what is the indices that it can travel? It is simply 4, 7, right? Because even the robo is not a wall, so 4 or 8, 4 or 7 is same. Because anyway, finally we are finding the walls. So anyway, 4 or 7, 4, 8 is same because there is no there is no wall at 8. So let's assume we are taking 4 and 7. So for 4 and 7, so this is the final pair. The pair 4 and 11 is wrong. Why? Because there is a robo which is less than the end position of the bullet. So it cannot go to that. It will be simply the end minus 1. So if there is some robo, so if I plus 1 is less than n, so that's why we have sorted the robos. And then r is equal to, we are minimizing re with the next robot minimum minus 1. So that when the bullet reaches the next robo, it will stop there. So simply we are making minus 1. And then find the lower bound and upper bound as we discussed. R of capital R of I is the wall's indices that are covered for this range R is to Re. So we found upper bound and lower bound, and then R of I is equal to R start and R end. So what does this mean? So capital R of I is a pair where the pair indicates that is the indices, the range of wall indices that will be destroyed by choosing right. And similarly, L of I is the range of walls affected when choosing a left firing bullet for the present row. So hope you got this both R of I and L of I. And then simply dp. So we have other two functions where length is the number of walls affected, which is simply difference plus 1, and this is the overlapping one. So find the maximum of these both and return these one. Return the range. So we discussed these both in code. And now, so coming to first row. So coming to zeroth row, we don't have any before choices. So first, for the first one, what is dp of I of 0 and dp of I of 1? It is simply the length of L of 0, length of R of 0. Because length is effectively the number of walls. So length of L comma 0, because there is no I minus 1, we are just simply making this. So what is L of 0? So L of 0 is the range of wall indices that are destroyed by choosing left for the present row, and similarly right. And now start from I to n, and we have two choices. So we have two choices when we are assuming for left. So when we are assuming for left, then what is the maximum? It is simply the before count minus overlapping one with the present one. So, so let's simplify this. For example, we are at robo type. So what we discussed at robo I, we have two choices, right and left. So even for right, we have dp of I minus 1 comma 0 plus count of R of I. Why R of I? Because we are assuming that we are firing for R. So dp of I minus 0 comma minus 1 plus 0 plus count of R of I minus overlapping between R of I and R of I minus 1. Right? Because we are assuming this is also right and 2 is also right. So count of the new one minus overlapping of both rights. So this was exactly it is this. So let's forget about these two. So let's comment about these two now. And now let's assume that we are dp of I of 0. So we are choosing right. So if we are choosing right, so let's assume that, so just check the code whether 0 1 is swapped or not. So let's assume that 0 is for left now. So for left, dp of I of 0, what is this? It is simply the new wall indices count. So it is simply length of left of I plus value of 1. So what is value of 1? It is simply the old one left or right. So here we fixed the choice for the present one, but we still have the flexibility for choice of before one. So value of 1 is the maximum of those both. So now what is value of 1? It is simply maximum of both choices. The first one is the previous one is left. So the old left minus overlapping between both left. And similarly, the old one is right and overlapping between old right and old left and present right. So just check the code. Hope you understand this. And finally, we are returning the max of this both. In this way, we can find the answer. If you have any doubts, comment below. See you in the next video.